Okay. All right. Anyway, yeah, that's right. Let me figure out how to do something about the noise, which that would probably do. All right. All right. So we got about 5 minutes before we officially start. So I just want to talk about the news a few minutes, and then I'll explain what's going on here. All right. So there's always lots of interesting news in this business. That was pretty interesting. And that, pretty exciting. And really shows that. And that's probably enough. Well, a lot of good stuff. Let me just see how many of these I have time to talk about before the official time. A lot of good things happen. So this is pretty interesting. As you know, America is having an unbelievable opiate crisis. The statistics are amazing. The number of people dying from opiate overdoses is something like 6 times what it was just a decade ago, which is pretty surprising to me because, you know, I grew up in the 60s and 70s when everybody learned about heroin and they pretty much quit using it. And now they're all using it again. And it is the drug companies, the legal prescription companies have created this crisis. And now they even caught the individual financiers who are well-known beneficial people. So these Sattlers, growing up, Purdue Drugs is the one that made OxyContin, and this Sattler group of philanthropists are the ones that funded it, and they just ruthlessly tricked doctors into prescribing this. They lied to them about how addictive it was. They would meet with them many, many times to bribe and cajole them into prescribing more of this stuff, and it is pretty impressive. Here's how fast opiates kill you. This is how many people die that are not taking opiates, and this is, as their dosage of opiates increases, how many more of them die. It's really pretty amazing. So exciting stuff, interesting to see. In my mobile device hacking class, we're playing with a 0-day this week, which is ES File Explorer, which is very popular. If you run this on Android, all your pictures are distributed to the local area network, and they have been for years, but nobody noticed, with no authentication. And Craig Young proved that you can access them over the internet with DNS rebinding. This is a big issue this year because since the Internet of Things has appeared, many people have their houses full of smart devices, and most of those smart devices, if you connect from inside your home, they just let you in. They consider your presence on the local network as sufficient evidence that you are authorized. And because of the DNS rebinding attack, it is possible to come in from the internet and fool the local device into thinking you're on the local network. It is, in fact, extremely difficult to do. I tried to assign it to my classes as homework last semester, and it is very frustrating. I have to set up a very strange page and refresh it many, many times over about an hour to trick it into thinking you're local when you aren't. But in principle, it can be done. And perhaps with large enough targets, people will be motivated to write better software to do it more effectively. Yeah. A DNS rebinding is you have a domain name like samspouse.info, and then you have your own DNS server that tells what address it is, and you configure your DNS server to sometimes give it the real public address and sometimes give it a 127 address. And then you make a page that keeps refreshing, and so it refreshes and refreshes and does a fresh DNS lookup, and eventually the DNS resolves it locally, and now it thinks it's on a local network when it does things. So it's a little tricky to set up, but you can create traffic which really came from the web, but which appears to have come from inside your house. Yeah. If you don't have local access, why not use proxy into the IoT? Of course, it'd be much better to install some kind of agent locally and then proxy, but that would require administrative rights on some device. And what DNS rebinding is essentially is a way to proxy with nothing more than a web browser, where just a person viewing your web browser is unaware that a page is refreshing and unaware that that page is forwarding traffic and changing the address. That's essentially what it is. And it is, in principle, possible, in practice, pretty difficult. But anyway, that means you could totally steal people's pictures off their Android phones. And there's a big one. People are getting real sore about Facebook. And this is one of the main investors saying Facebook has lost their way and they become evil and everything. It is interesting to read. This is a big ethical debate of our time. I do not agree with anything he says here, but he says it very clearly. And this is certainly one popular opinion. I've heard this, I've read about this all the way back to the time of Confucius. Every generation says whatever the new generation has to communicate is terrible. It's poisoning their mind, it's destroying society. The printing press is going to ruin everything. Blogs are going to ruin everything. Television, radio, vinyl records, they're all going to destroy the minds of our youth and the human race will be demolished. I've just heard it so many times, I don't have much sympathy with it. But this is the latest version of it. And we will see what comes of it all. I think what is going to come of it all is in the backlash against Trump, there's going to be a push to the left, and then we're going to have strict media censorship with sort of Mao-like thought control, which is what the extremes on the left want. They think if you silence everybody from saying forbidden thoughts, you can extinguish those forbidden thoughts. It is, that's what tends to happen when you go too far to the left. And when you go too far to the right, you just get rapacious businesses stealing everything. And somehow we seem to have lost all interest in being in the middle in America lately, which I wish we could get back to. We really ought to explain that we are not a pure capitalist nation. We are not a pure raving socialist nation. We're kind of mixing the two. And we should not attempt to be pure one way or the other. That's my feeling, but there's not much of that happening. And I think we're up to the official time. So let me explain what's going on here. You probably noticed that I'm not Elizabeth. And yet this class is going to be taught by Elizabeth, but it's going to really be both of us working together. Right now, Elizabeth is off fighting the forces of evil, and she's not going to be here today, but she'll be here next week. And as we go forward, we will be trading off responsibilities for this class because our college is getting very heavily into cyber competitions. And that means we got teams that are traveling off, and some of it has to go there. So it takes more than one teacher, really, to keep up with this stuff. So the point of this is to learn the more advanced penetration testing techniques than you saw in 123. You're going to start writing your own tools. We'll do some of that today. And then we'll be covering more advanced techniques. And there are two ways to go here. One way is to do the ordinary homework assignments. There's a bunch of the ordinary homework assignments down here you can do, which are fine, where you set up machines and do the kind of projects you did in 123. Where you set up a specific attack, make it work, and turn in a screenshot. And that is a fine thing to do, but you might want to do a more advanced task, which is to move directly into the cyber competitions. Some people will want to do that, and some people will not. So what's happening is this class goes from 9 to noon and has the usual textbook chapters and projects. And then about 8 weeks during the semester, there's going to be this red versus blue. We did a prototype of this last semester about 3 times. Head-to-head competitions, something I've wanted to do for 10 years, and now I finally figured out how to do it. And so we're going to be improving this, and the first 3 or 4 of these are all extra credit for anybody in any of my classes, and extra credit for any of you that want to do it, starting on January 31, and every couple of weeks after that in a sort of irregular schedule. You'll see here, we're going to do this. It'll last for 1 or 2 hours. People will be attacking and defending. The attackers and defenders will both have scripts to guide them, but there will also be things that are not on the script they can discover, and they'll be earning points and scoring and such. And this is, a lot of other colleges are very interested in this. So by the end of the semester, we are going to have real competitions against other colleges. And many of them want to participate. We're going to have this semester, by the end of the semester, we're going to have a couple of intercollegiate events that will be small scale, just one college against one college, probably remote. This whole thing is supposed to be small enough to be a normal homework assignment, not a huge thing like CCDC where you practice all year and have one giant event that has enormous prizes and consequence. This is just a slightly more fun version of homework. That's all I'm trying to accomplish here. But community colleges in general really want that because they're not really ready for the big time and they want some way to get there. So it's intended to be a small scale training product, which would be more accessible. Anyway, so do that if you like. Various people will be showing up for them. And there's, all right, any questions about anything? Did anybody need an ad code? Well, okay, quite a few. I'll bring them up later then after. So I'm not going to lecture from the book today. I want to just start you on Violent Python. That's this book here, which is optional and easy enough to find all over the place, but you don't really need the book. Let's just talk about, this is a simple example. If you have not taken any programming, you don't really have to before this, but it would be nice to know a little Python. But even if you don't know any Python, it's not that hard to do. So let's play some games here. Now, if you have a Kali Linux machine or a Mac, you've already got Python. If you have a Windows machine, you can install Python on Windows here. One thing to realize is Python is open source, and there is a general rule which I cannot think of any exceptions against, which is every open source project does not install correctly on Windows. This is because Microsoft keeps on changing Windows, and they keep on making it more and more complicated, adding more and more features which seem really stupid unless you're deeply into the Microsoft religion. I mean, Microsoft is basically a cult group. They have special language, they have special beliefs, they talk a certain way. And if you want to work at Microsoft, you have to sort of join that religion and buy their stuff. And they kind of is isolating for anybody outside. Anybody that doesn't use Microsoft much finds them to be offensive and crazy. It's a big culture clash. So Microsoft thinks nothing. For example, they've taken away most of the features that most people used to use to maintain their servers, like image-based backup and system restore that we all relied greatly on XP and Windows 7. They've taken them out or changed the name or hidden them because Microsoft's attitude is everybody should have a deployment server, pushing whole images over the network, because that's what enterprises do, and they just don't seem to know or care about anybody that isn't a huge corporation. They think we all have an IT team and 1,000 machines, and we can use these bafflingly complicated products all the time, and we don't mind setting them up. So the open source community that isn't that interested in Microsoft can never keep up with this stuff. So the installers are typically unbelievably out of date, like they're really designed for DOS or Windows 95. And you can sort of run that on a modern version of Windows, but it doesn't really go on correct. So anyway, I'll look at these instructions. You'll find that if you install Python on Windows, it won't run until you make a shortcut so that the modern versions of Windows can find it. Because it installs in a place that hasn't been the correct thing to do on Windows since Windows 95. It puts it in C, Python 2.7. Now, putting software right in the root of C is something Microsoft gave up after MS-DOS. But the Python people haven't noticed yet. Because, you know, the reason you do Python is because you kind of hate Microsoft anyway. So anyway, but Python is fantastic. So let me close my windows, make a new window. If you just open a terminal on the Mac, you've already got Python. By the way, I should make another sort of apology. If you type Python on the Mac, you get Python 2.7. Now, technically, Python 2.7 is old and obsolete. We shouldn't be using it. And they keep saying they're going to call it, they're going to deprecate it and say you quit using it, which they've tried over and over, sort of like HTML4, and for that matter, HTML2. A bunch of people would like to say it's over, but the problem is there are 2 billion pages on the internet written in HTML2, so you can never stop supporting it. And Python 2 is much, much easier to use than Python 3 because Python 2 is only for English and ASCII. Python 3 uses Unicode in all the international languages, which is, of course, why a lot of people would like to say abandon Python 2 and go to that. But if you're actually just using English, Python 2 is a lot easier to use. So that's what I'm going to use because my interest is not to make you a good programmer. If you're a good programmer, you probably have much better ways to do everything I want to show you. I'm trying to take people who have no programming ability at all and make them into lousy programmers. So you're a small step up. So we're going to use the easiest way to do everything, not the best way. That's why I've had some computer science people say, I should just be fired for using this book. This is a terrible book. This teaches people bad habits. They're going to have to unlearn it later. If you want to be a real developer, you have to do a much more sophisticated thing than what we're going to do here. But if you're just a hacker or a pen tester, then it would be nice to know enough scripting to automate simple things, to make them work once. And that's what we're going to get here. The technical euphemism for this is rapid prototype, otherwise known as sleazy, miserable, bad coding hacking. Anyway, so, all right. So let's do some port scans. You can do port scans with Netcat or Nmap, but you can make a banner grabber in Python. Now, you could use a text editor, and there are, of course, friendly text editors and Python environments, but I recommend using Nano because as a pen tester, you are frequently going to get a command line on a host, and all you're going to have is a command line interface. So you might as well get used to living entirely in the command line, even though it is incredibly old-fashioned and primitive. That's often where you have to go. So I use Nano. The real pros use VI, by the way. If you know VI, feel free. But unless you write code all the time, VI is very annoying. Nano is what the wimps like me use that can't be bothered to remember VI, and you can edit something. So I'm going to make, let me make a folder. I'll make directory 124 maybe. Okay. All right. So let's make a file called grab.py, and there's my file. Okay, now the reason why Python is easy to use is because other people have done all the work for you. So all you have to do is import a library somebody else wrote and use it. Now this, by the way, is a really important issue. Many people are suffering through supply chain attacks. Kubernetes got it, everybody got it. It is turning out, if you actually write a program and make a web page using like Node.js or Angular or something and publish it, you only wrote a tiny part of that code. You're using libraries and they're using other libraries. And so it turns out you've got about 100 libraries and they're written by random people you don't know. And the criminals are onto this. If you write a library for PHP or Python, or you have a browser extension that gets popular, you will start getting emails from criminals saying, I will pay you a pile of money to buy this from you so I can put poison in this code, which will infect everybody who's using it. And people sell out because all the open source community is kind of a swindle. They tell you the whole world is volunteering their time doing this out of the goodness of their heart. Well, you know, what happens is somebody did start volunteering, spending their time doing this, and then it turns into a bigger and bigger burden as everybody floods you with requests and fixes and patches. And this army of people to help you does not really appear, and they're not much use when they do appear. So almost all open source projects are one guy spending all of his free time for no money maintaining something until they finally get burned out and quit, and then it's gone. Anyway, just be aware this. If you talk to like the MIT people, like Richard Stallman, they have this religious belief that the open source community is this angelic bunch of experts contributing their great wisdom to us all, and it will go on forever, and there's a giant community all working together that love each other, making this utopia, and the reality is a whole lot nastier than that. But anyway, so somebody wrote this socket library, which is a low-level Berkeley standard sockets. When all of this started, there was in the 60s and 70s, you could buy computers, but you got a mainframe, like an IBM mainframe or a VAX mainframe. And the mainframe came with about 5 telephone books full of documentation for that particular brand of mainframe. So if you had a VAX, you had to learn VAX mainframe language, and you had to write all your code in that one language. And if you got an AMDAL, there was a totally different mainframe language. This was kind of a drag if you ever expected to network them. So in order to create the internet, they wrote Unix to be the unifying operating system. And in order to make Unix, they wrote C, which was the language to write Unix in. And thereafter, all you had to do was to write a C compiler in whatever specific language came on each mainframe. And now you could have the internet where computers could talk to each other without having to all be the same brand of computer. And so Berkeley made one of the early brands of Unix, Berkeley Standard Distribution, and they defined the networking sockets that led this, and that's what this socket library does. It is the low-level sockets that everybody uses. There are 3 or 4 standard methods like bind and send and receive and connect, and this is the fundamental operations that run the internet from the very beginning. And all later higher level applications like a browser, when you type a URL in there, are just using this in a couple of layers of libraries down. It's making Berkeley standard sockets. So that's what we got here. So we're going to use the connect method and connect directly to this server, attackdirect.samsbias.info, on port 22. The connect method does a TCP handshake. It sends a SYN, the server sends a SYN ACK, and then it sends an ACK. And after that, it's ready to send some, and this doesn't send anything more. It's just whatever comes back, s.receive, up to 1,024 characters, it prints it on the screen, and that's it. That's all this does. So let's save that and just run it with Python grab. Just give it the name of the file. There are, of course, ways to make it executable as you don't have to type Python in front, but I'm such a sleazy guy, I don't even care about that. I just want to make it work in the simplest possible way. So this connects to my server and it gets a banner saying this is an SSH server. This particular server of mine is just a plain old vanilla Ubuntu Linux server running SSH. So if you do the handshake, it gives you this banner to tell you it's running Ubuntu Linux and SSH on it. So that's fine. This is the simplest kind of port scan. Now, let's consider a timeout. Let's copy this. I'm going to copy. By the way, here's another fundamental rule of programming. The beginning programmers, the number one mistake beginning programmers make is they start typing right away before they think. Experienced programmers spend 80% of their time planning, and they don't write a single line of code until they planned everything they're doing. Now, for these simple projects, that's not justified, but another huge mistake is people write a whole page of stuff. Then when they run it, it crashes and they don't know where the error is. Yeah, we're just waiting. Okay. Anyway, so one really important rule is, in the first place, only write a couple of lines and then test it. Write a couple more lines and then test it. Here's another really helpful rule, which most students violate for the first several projects until they begin to catch on. As soon as anything works at all, save it and change the name. Because you will often find that you go off down some dark alley into some horrible place where nothing is ever going to work, and you wish you had that thing that worked an hour ago. So I have a lot of students that do a project, they keep having one file, and they keep modifying that file for like 3 or 4 projects in a row, and you'll be sorry. So I got grab working. So the very next move is copy grab to grab2.py. So that if I file up grab2, I can go back to grab1. Now I nano grab2. And all I want to do, but it's got to spell it better. All right, all I want to do is change it to port 80. So I'm going to connect to the same server on port 80. Now that should work, right? Because that server is in fact a web server. If I type that URL here, direct.samsclass.info, that is a real web server. It's serving up a web page. So you might imagine this should work. Let's try it. So if I do Python, grab2, it just hangs forever. And it will hang for like 2 or 3 minutes. Very annoying. Now, the reason this happens is because the server is listening on port 80. And when you send it a SYN, it will send a SYN ACK, and you can send it an ACK and complete the handshake. But then it doesn't do anything because SSH is intended to be used by a human at the command line. So when you connect to SSH, it sends you a banner. Then it'll ask you to log in. HTTP is not intended to be used by humans at the command line. It's supposed to be used by browsers. So it doesn't give you a banner to tell you what's going on. It assumes that you are an automated process like a browser, and you know how to send a proper HTTP request. And it doesn't reply until you send it a real request. So you're just going to sit there until it gives up and hangs up on you. So if you want to do a port scan, you got a problem, because there are ports that are open and then send you a banner you can see, and there are ports that are closed and send you a reset, but there are a bunch of ports that are open and will take the handshake but then send you nothing, and your scanner will just wait forever for a timeout. So you need to add a timeout to the code if you don't want to be waiting a really long time. So there are ways to do it, but the simplest thing is set default timeout. So I'll add that line to my code. I'm not Python, but nano. Okay, so once you define, this, by the way, let me mute all people so they don't irritate each other with barking dogs and such. All right, so here I can set the default timeout for all sockets, which is what I'll do. I could also set it for one socket if I really cared, but I don't need the details. Timeout 2. Maybe I'll make it 1. That's probably fine too. Sure, that's 1 second. Set default timeout. Okay, now, if I did that right, it shouldn't make me wait too long. I do grab2, good. It only waits a second or two and then hangs up. This is what I want. Okay, so now I can scan ports and fairly quickly tell if they're open or closed. So the next thing would be to put the port in a variable. Here we hit another fun thing. By the way, as always, now I got something that works, I'm going to save it and make another thing, grab3. Okay, so make grab3. Okay, now I just like to put things in a variable. So let's make a variable called target. And that's going to be this, and I'm just going to copy and paste using the terminal, not the nano, but the terminal. And then let's say port equals a 22 set. All right, and now when I connect, I'm going to go connect to target and port. Now, first let's see if this works, and then we'll talk about it, because a few things happened here that might begin to bother you if you know anything about programming. Okay, it connected, it worked, it gave me the banner, the SSH banner, so that program works. Now let's talk about this program. This is kind of horrible. I defined something called target, and I put a string in there. Then I defined something called port, and I put a number in there. I did not tell it that this was a string and that was a port. This is called loose typing. This is in fact horrible, and it makes life easier for beginners, and it makes much trouble later, including serious security problems. it's a whole lot cleaner if you use a language like C, where you have to tell it, this is an integer, this is floating, this is a string. Then you're in a lot more control. This is like driving on ice. Now, but anyway, it works in this case, so that's important. Now, if I were to do something that might look pretty harmless, like this, put quotes around the 22. Now it'll interpret 22 as the string 22. And what that'll do is break everything. Now it crashes. So here we have another fun fact. If you write Python in this sleazy way, you don't get any error messages that are any use. You get the default error messages, which are pretty baffling. What is this junk file here in meth? Return get header sock name. Down here, it actually gives you a clue. An integer is required. That's as close as you get to anything helpful. So if you write sleazy code like this, your error messages are going to be almost useless. This is why you must only write a couple lines and test it, and a couple more lines and test it, because it's going to be very hard to figure out from the error messages what the problem was. Yeah. An integer is required, yeah, this is a very good point. It doesn't even make it clear what line it is. The integer is not required here. That is a perfectly legal statement. The integer is in fact required here, which is not obvious at all. Also notice something else goofy, the two sets of open and closed parentheses. This is because the person who wrote the socket library chose to write the connect method. Now the connect method could have taken two arguments, one string and one number, but it didn't. It took one argument, which is a tuple data structure. You can have a data structure that contains multiple data. So you have to have two sets of parentheses, because the first one means, and here's the argument, and the next one takes the two variables and puts it in the quantity, which is moving all together. So this is why Python is in fact object-oriented, and you can write code that is reentrant and can be run in parallel and make multiple instances. You can do all sorts of super advanced things with Python, but you don't need to know that to do simple things. But you do have weird things here, which if you actually think about the details, give you a clue that what's going on here is actually a whole lot more complicated than it appears. So anyway, the point is this needs to be a number here. So my port should be a number is the simplest answer for that. And by the way, there's another solution. I could do this. I can make an integer of port. Now this is really horrible. Let's see if that works. It does work. So what I've done is the kind of thing you would never do in a proper language like Java or C. I made a string variable called port, then I changed it into an integer. Now it's an integer. This is like pretty darn uncivilized. But anyway, all right. So let's, that is a port scanner where I have the data in a variable. And so the next thing is I would like to take the data from user input. So I'm going to use this function called raw input. Raw input reads from the keyboard and puts whatever it gets in a string variable. So let's copy that, grab 3 to grab 4. These are banner grabbers. That's why I call them grab 4. Grab. All right. And so now what I'm going to do is target is going to be raw input. And I got to have an underscore here, not a parentheses. All right. And then in here goes the prompt string, which is going to be target URL. And then I'll set port equals to raw input. Got to spell it better again. Of port. All right, that looks pretty good. Let's see what that does. That's grab 4, Python, grab 4. Okay, now I got a problem with my quotes. So let's fix that. I got an extra quote up here. That's no good. Okay, let's see if that makes it better. No, don't do that. All right, I got to be slightly less sloppy typing. All right, my attack direct.sams class.info is this server, 22 is the port, and it crashes. Now, we've been here before. The problem is the port that I got from raw input came into a string. And you can't put a string in the connect method. So you need to put it into someplace. One place you could put it is here. You could also put it down in the call to connect. That would work too. But that should do it. It'll take the port. Now, this is going to introduce another sleazy bug. All right, now if I put in attack, I'm tired of typing this, I'm gonna put it in the clipboard. Okay. All right, so there's the URL, there's port 22, and now it works. Now suppose I did this, and I put a target URL of this, and I put a letter here, now it crashes. Because I didn't, now this is why I say, if you write real programming, you spend almost all your time handling exceptions. You take everything that can go wrong and you write special code to handle it. But if you're just a sleazy pen tester, you just want to make something that will work once, and you don't care if it crashes, if anything bad happens, you just want it to work when you do the right thing. So you don't need to bother with error handling. Error handling is a tedious activity and important for commercial code where you're going to sell it to people and they're going to use it who aren't programmers. But if you're just writing it for yourself, it's not as important, and we're mostly going to skip it. So anyway, now you can go. So there are some challenges to do. Once you've done the basic one here, these projects have a simple pattern. There's a basic project that tells you exactly what to do. So you can just copy the instructions. And then there are challenges for extra credit where you have to solve puzzles without instructions to try to reinforce your learning. So here you got to find a service, for example. You need to just try a lot of ports, like 1,000, 2,000, 3,000, until you find this congratulations message. And so I could actually use this thing right here for that. If the target is attackdirect.samslash.info, which is still here. Okay, if I go to 1,000, I get connection refused down here and a bunch of error messages. So 1,000 is not open. But if I go to, say, 2,000, oops, this one, and 2,000, then I get connection refused also. But eventually you'll start getting answers. And some of the answers will be other things, but one of them is going to be congratulations. Then there's port knocking. This one here really slows people down. Port knocking, you have to make 3 connections. This is an old-fashioned way to make a secret backdoor into a server. This was used by malware, and then it was used by a lot of legitimate system administrators. Here is a disturbing situation. If you are a network administrator, there was a survey about 5 years ago. The Register magazine surveyed network administrators. He said, how many of you have a secret backdoor into your network that your boss does not know about? And the answer is 80% of them. And they said, how many of you would get fired if your boss found out? And the answer is 80% of them. And you say, why are people so irresponsible to do this? The answer is because their boss is like Dilbert's boss and doesn't understand the consequences of technical decisions. So you ask your boss, can I have a secret personal backdoor onto the server? They say, absolutely not. We have compliance regulations and oversight and a security policy, and we can't have some ridiculous thing like that going on. Then you go to Hawaii and the phone rings, you're on your surfboard, and the boss says, the server is down. You have to fix it. So how am I supposed to fix it from here? I said, well, I have a way to fix it, but you'd probably rather not know how. I'll take care of it without having to give you the unpleasant information of how I take care of it. This is why one of the things that advisors to the president have to learn, I've read plenty of articles about it, is they have to learn to shut up. If you're like an FBI agent or CIA agent and they take you in a conference with the president, you very carefully answer only the question you were asked, because there's a bunch of things the president is not supposed to know. Like, we're breaking laws right and left. We're executing people, invading countries, killing citizens, forging identities, going into our allies' nations illegally and killing their citizens and smuggling them out. We're doing all this, everybody's doing all this stuff. And the president has to pretend not to know about it. There's a lot of this. This is the way real authority figures work. Anyway, so this is one of the early techniques to do this. There's a later technique called single packet authentication that's considered fancier. So you want to open a door into the server. You could run SSH on some port. If you run it on 22, everyone's going to find it. So you might just move it to another port, like 5,000 or 10,000, and that will stop complete amateurs from finding it. But anybody that can run Nmap will find it pretty strong. So that's not a very good solution. So what you wish you could have is an SSH port that nobody could find with a port scanner, like the kind we just made here. So what you do is you make port knocking, and here's how it works. You have to get a SYN going to a port which is not open. Then SYN goes to another port which is not open, but a process on the server detects those knocks and opens another port for just a few seconds. So if you know the magic pattern, you knock, and then you can connect. But if you just run a scanner, you'll never find it, because you have to have those 3 things exactly in order. So here's the knock. There's a hidden service on 3003. it's closed, but it will open if you connect to 3100 and then one of these, it'll open for a few seconds. So you have to write a program that will make 3 connections, connect first to 3100, then to a variable port, and then to 3003, and try moving the variable port until you actually get a connection to 3003 and you get the banner. So it requires basically 3 copies of this port knocking script scripted together. Anyway, so that's a challenge to solve. And considering our structure here in the time, I think I'm just going to do one more level of this, and then I'm going to quit lecturing, and I'll have the ad codes, and I'll go up to the lab, and people can do this. But let's do HTTP requests. Remember, we already did port 80, and when you connect to port 80, you get no banner, and we don't know what to do. So you can make HTTP requests with Python. You're basically writing your own browser. It's a little text-only browser, but it's a very good thing to know how to do because you can use it to hack into servers. So what you have to do is the same thing we've done. So let me make HTTP1. I'm going to copy. Let's see what I've got. I've got grab3. I think grab3 is pretty good. Let's see how grab3 is looking. Cat prints out the contents of a file. Grab3 was this one. That looks pretty good. Okay, I'm going to copy grab3 to HTTP1. And I always put a number in it. This is the very infantile version of version control, which you have to get into a GitHub and stuff. You should always have a version. Always keep the old version and move on, because something else might happen that wants the old version, and your change might turn out to have unintended consequences and so on. So HTTP1 is here. Let's take a look at it. Okay, so my HTTP1, I want to connect to port 80. That's the first thing. Okay, and I don't really need this nonsense with the integer stuff. That was a demonstration. We can get rid of that. Okay, so now I'm going to connect at port 80, but it's going to just time out on me. So I have to actually send a request. So you do s.send, and now you can send a request. And a request, the simplest request is a head request. If you remember from 123, we talked about HTTP methods. There's get and post and head and options. So head is a simple request. So it's got to put it in quotes. The HTTP protocol says send head/HTTP/1.1, then a carriage return, then the name of the host. And in that case, I'm going to have to add the name of the target, because you have to have the required by HTTP 1.1. You have a verb and then the name of the URL to host, and then /HTTP 1.1, and the next line must say host. In fact, let me show you. Here's, if I go to my web page here, which loads over good old-fashioned HTTP, you can view that if you view developer tools. And let me find them. It's view tools, web developer. There, web console inspector, one of these things. Let's try toggle tools. Okay, this is in Firefox and it's in Chrome. And if you go to network here, there we go. I can refresh that page, and here we'll see the actual request that got that page, which is a good place to start. So if you click on that get, it will show you the get request here. And this version of the tools is determined to make it look pretty. So let me digress a little further and just open it in Wireshark. You hopefully have used Wireshark before. If I sniff on the network, I can filter for HTTP, which is actually not that common anymore. Almost everything is HTTPS. And I can refresh this page. And now you see a page loading from here. And if I right click and follow the TCP stream, it will show you the request. This is a real web request in all its glory. And what it did was it sent a get and then a host name and then a bunch of other stuff like cookies and referrers, which is not really necessary. It's enough to just send the first couple of lines and the blank line to do simple requests. The rest of that stuff is for fancy things like how long it should be cached in the browser, which really aren't necessary all the time. So what I'm going to do is send HTTP and then the host. And then I think I just need a carriage return line feed, a couple of them. Let's get rid of some of this stuff. Get back to the HTTP. Okay. Yep, just a couple of line feeds might do. If you have a more modern version of Apache, it'll actually require \r/n for each of these. But I think my server is running a really old version, which will let you get away with this sleazy response. We're going to see Python, HT, and okay, timed out. Maybe it does require The /R backslash. What's that? Oh, the timeout? You mean 1 second? You don't think that's enough? Well, maybe let's try /R/n. See if that's necessary on my server. I'm not sure how old my version is, but if you see a mistake, let me know. Let's see if this works. If that does it. Nope. All right. Oh, it timed out. Head. Did you see the mistake? Because I didn't. What's the mistake?
You need to change functions.
Change the send. Oh, I didn't do the connect. Oh, I thank you. Good. You're right. I have to connect and then send. Very good point. Thank you. Good. Ah, good. Now I get a response, which is 200 OK. Which now I probably don't need that /R/n. Let me try getting those out because otherwise it'll frustrate you if you try following my instructions. I think on this server you don't need both of them, although on many servers you do now. Yeah, all right, good. So this is HTTP 200 OK. So now I can connect to a server and send a proper web request and get a web response. The only thing is a head request is pretty boring. It just tells me the version of server that's running. It doesn't give me anything useful like the actual web page. So I'd rather make get. So let's copy HTTP here and make get 1.py. And then nano get 1.py. And let's just change that verb from head to get, which is the usual verb your browser uses to load pages. And I don't need to change anything else. And so if I run that, now I get the page which has all the HTML stuff. So this is, I get the header here, which you don't normally see in your browser. Your browser gets this information and does not put it on the page. And here's the part that your browser uses to make the page you see, the HTML, which you probably learned in other classes. So now I can fetch a page over the internet. And now I can catch a login. So if I want to do a login, the simplest thing to do is catch it in Wireshark or developer tools. I guess I'll use Wireshark for this one. So if I want to log in, let's get my Wireshark running. Close this, and I'm going to just restart Wireshark. And I'm going to filter for HTTP again. Okay, so I'm going to put in foo and bar for this username and password and submit it. And it's going to warn me that I'm sending it over HTTP, which is really considered a bad idea these days, but I'm going to do it anyway. And now it doesn't like foo and bar. That's not a good name and password, which is fine, but I don't really care whether it's good or bad. I just care about how it was sent there. Somehow it was sent to the server. And if you follow the TCP stream, you'll see the request. So this is the Python request that sends foo and bar to the server. And you could, in fact, send that exact request this way. You could just highlight it and copy it, and then you could just put it right in the script. This is really sleazy, but this is a way to get started. So let's take, let's copy get to post1.py. And then nano post. Okay, and now I'm going to send a request here. So I'm going to, I don't know, I guess I'll do this. I'm going to make a variable called request. And here's a cool thing about Python. You can use 3 quotes, and now you can paste in text that contains carriage returns, and it will understand it. You can have a multi-line string. So that is the whole string, which will send the whole thing the browser sent, including the post, the host, all this stuff about the user agent and caches and stuff, and then the username foo and the password bar. So that's in a variable called request, because I named it REQ here. So if I want to send that to the server, I can just put that here instead of this stuff, REQ. So let's say do that, and then run that and see how it looks. Okay, now this is, I got a 200 OK. That means the server understood the request and it delivered something. But what it delivered is unreadable garbage. So this, it appears to have worked, but it's not really doing much good. And the problem is in the request. Since this works, by the way, I'm going to copy it. and go to post 2. This should just be a habit. Don't think, make a copy of anything that does anything good. Okay, then post 2. Let's try to make it so I can read the output. Here's what it sent. It sent the request saying post. Wait, that's post. I didn't want that. I'm doing not post. This is, well, this is post. Yeah, sorry. Okay, I'm catching on. All right. So this is post 2. All right, so it sent a post, sent a tap direct, user agent accept. Notice this thing right here, accept encoding zip. That means it's allowed to zip the file before sending it to me, which makes the web server faster, but that's why I can't read it. It's zipped. So if I don't want it to zip things, all I have to do is delete that whole line. If you don't tell it that you will accept zipped stuff, it won't send you zipped stuff. So that's all I need to do is get rid of that line. And now if I run that, post 2, now it gives me 200 OK and the header, and then it gives me stuff I can read here. So now I sent it foo and bar, and it told me here credentials rejected. So I can automatically try to log in, and I can tell from the result whether I got in or not. So what I'm trying to do is build my way up to a brute force attack, so I can try a whole list of usernames and passwords until I get in. Now there are tools other people have written that does that, but we're trying to learn how to write our own tools here. And the first tools we're writing, before we wrote our own version of Nmap, now we're writing our own version of Hydra, real such. So anyway, this is, all right. So now, suppose I want to try another username and password. Since this worked, I'm going to copy it, post 2 to post 3. So let's try another version of this. Suppose I want to use a different username and password. Well, here's the username and password. So if I put root and tour here, for example, I might want to see if that will get me in. So let's save that. Oops, hit some bad key. Okay, let's run that. Let's Python post 3, I guess. All right. And what happens is it just hangs there. Nothing happens. That's irritating. Then it times out. So I wonder what the problem is. Now, here is how you diagnose problems. This is a very useful technique. I've got Wireshark looking at the traffic. So I'm going to restart the capture, get rid of that filter and go back to HTTP. Now I'm going to run my script, which is here. Okay. My script sent that up to the server. So I'm going to right-click that and follow TCP stream. That's what my script sent. Now I'm going to use the real web page and send it again. I'm going to send root and tour and send that up now and continue. Now that worked and I got the message. So the question is, why is that different than the one I sent? So I close this one and the, let's go back to HTTP. Okay, the first post is my Python script. The next post is the browser. So this one worked. I can follow the TCP stream and I can open both windows at once and just compare them. So this is the good one on top and the bad one on the bottom. And let's see if we can spot the difference. They send a post, they send u equals root and p equals tour. What's the difference? Somebody out there must be able to see it. The content length. This is 13 and that's 11. The content length must tell you how many characters there are and what you're sending. And I made the username and password longer. So it's u equals root, that's 1, 2, 3, 4, 5, 6. P equals tour is another 6, the ampersand is 13. This number has to be the total number of characters and what you send down there. If it's not, the server will not accept it. So I have to include that in my script. So I have to write a little bit more to my script, although it's not too tough. I think we're done with Wireshark. I'm going to quit that. Let's fix our script. Now this one did not work, so I'm not shy about modifying it. So post 3 is not working. So the first thing is I want to make a username and variable. I'm going to put name equals root and password equals tour. Okay, and then down here, I'm going to put those in variables. So it's going to be u equals plus name plus and p equals. This should work. I think that should do it. Now, the problem is I need to fix the length. And the length is here. So what I'm going to do is make two different requests. This is going to be request 1, and this is going to be request 2. There. And now I'm going to send request 1 plus length plus request 2. That's my plan. And now the length in the middle, I'm going to calculate. So I'm going to set length equal to, it's the length of the name plus the length of the password. And I think I have to add 5 because the name is 4 and the password is 4. I need to get 13. So adding 5 should do it. I think it'll work. That's going to give me the length. The only problem is that length is going to be a number and not a string. So I'm going to have to make it a string one place or the other. I could do that here, for example. There are many ways to skin a cat, of course, but that's, if I've done everything right, this is going to work. Otherwise, I'm going to have trouble, but I can tell by looking in Wireshark. So let's see if I did it all right. If I run this one, it gets all upset. Request 1 is not defined and all that. So let's go back and see what I did wrong. Oh, they didn't change the first one to request 1. Okay, request 1 is the first bit of this up to the length. Request 2 is all the stuff after the length, and the length goes in the middle. This might work. Let's see. And it timed out, so something's wrong with my request. So this is why Wireshark is your friend. Let's go back and run Wireshark again, sniffing with HTTP. I'm getting closer, but I'm still not right. So I run my script. Okay, and now I'm going to run the real login here. Okay, so let's get back to Wireshark. We can stop sniffing. There are 2 post requests. Here's the one from my Python script. Okay, and let's see, maybe this, yeah. And here's the, let's go back to HTTP to see them both. Here's the good one. Okay, so there. All right, the browser's on the bottom and my script is on the top. What's going wrong here? Content length 13. Oh, it's got quotes and everything in there. This is all messed up. It's supposed to be u equals root and b equals store, and it's u quote equals, something went wrong with my quotes. All right, I thought I might have cut too many corners there. Let me try this again. That's a pretty simple set of problems. I'm thinking the problem is with these triple quotes. I'm mixing triple quotes and single quotes. So what I'm going to do is just put in that request 2 here. And now I'm going to change, make request 3. And that's going to be u equals plus name plus p equals plus password. There, that's more likely to work. I'll just make a simple multi-line thing to get down to where it goes, and then a simple string here. And so now it's going to be plus request 3. That might work. 3 pieces of the request. At least it's getting closer. Let's see if that works. And it does work. It now accepted that I sent root and tour, and it gave me the answer, which is my credentials are rejected. So now I can try to log in programmatically. So we're almost ready to hack into a server. The only thing you don't have is loops, because you want to try a whole list of usernames. Loops in Python are incredibly easy. So let's nano loop 1. .py. Numerical loops, which are probably all you ever really want to use in most cases, work like this: for I in range of 5. Now, here is something that really annoyed me because I came from the world of Fortran and then C. In C, white space does not matter. In Python, it does matter, which I found very annoying. And the way Python works is every time you have an if or a while or a loop or anything where the first command starts something and it applies to a block of code, you have to put a colon. And after the colon, you have to indent the lines after that. No, it's essential. You must indent. That's what really annoyed me, because in C, you don't really have to indent. But in Python, you must. And you have to indent every line exactly the same. And when you stop indenting, that's the end of the loop. So that's what confused me here. So if I go on here and print done, there. Let's see what this does. So if I Python loop, it prints 0 hello, 1 hello, 2 hello, and then done. So the hello is inside the loop and the done is outside the loop. And it is the indentation that tells it that, which is actually pretty nice once you get used to it. But at first I found it very frustrating because I expected to have a curly brace at the start and another curly brace at the end, which is the way C does it. And I thought that was the right way to do it. And Python does not do it. So if this means if you go here and get rid of that indent, then the hello is not in a loop anymore. So if I run that, now it's 0, 1, 2, 3, 4, hello, done. And what's even more annoying is if you put one space there, which you might easily do by making a mistake, now the whole thing doesn't work at all. Unindent does not match any outer indentation level. Your indentations have to match or it is a syntax error, which I found very annoying until I got used to it. This also has the strange effect that I often have code and then I want to put it in a loop and now I have to go add a couple spaces in front of every line. I'm sure there's a smarter solution, but that's all I know how to do. Yeah.
Question is, I know it's too detailed, but does Python see the difference between indent command versus space or how?
I think it does. In fact, it's a very good question. I think it knows the difference. So let's try this. If I indent this one with a tab, and then I go to this one and indent it with enough spaces to go to the same place, I don't think it'll accept them. Let's see. Yeah.
Well, just like to avoid doing that, if you try to copy this program over to another system, certain like operating systems or text editors will interpret that differently.
Yeah, this one, Nano, in fact, it worked. Yeah, that's another thing I should mention. Here's a horrible fact. If you take online documentation, like for example, Google's official documentation to put a CAPTCHA on the page, if you copy and paste their code, nothing will work. This happens all the time because things that are pretty for humans are written using like Microsoft Office and they have curly quotes and funny characters like non-breaking spaces. And when you copy them to Unix, Unix doesn't know what they are. This is a huge problem. If you copy code from the web into a browser, you'll often fail completely and you just have to retype it. This is a very big annoyance and thing to be aware of. You'll hit it over and over again. Yeah. If you can find something that really removes all the special characters, and I think there are some methods, I haven't found a good way to do it. I think there are special Unix commands to remove special characters and such. You really need to scrub them. Doc unit? DOS to Unix. Okay, thank you. I should try it. I can't ever remember when I need it. So anyway, so now that's a numeric loop. Let's put an alphabetic loop here just for completion, although I don't highly recommend using them in these projects. But let's make name or fruit in, and I think it's curly braces. We're going to see apple, banana, orange. I think maybe I'm supposed to be square braces. All right, there. I think it's square braces. Curly braces are dictionaries, which I do not intend to get to. So if I did it right, that will go through the object called fruit. There. And if I did it wrong, it's an instructive example. All right, so that's the plan. Let's see what that does. Yeah, it worked. Okay, so it went through the numbers and then it went through the fruits. So you can now loop through names and passwords and try them to get in. There is, so there are a couple of challenges for you down here to do. So once you've got the ability to log in, then get all that working. And now once you know how to make loops, the challenges that go with this are down here in 2x. And there's a series of them. So first, you have 4 possible usernames and 100 possible pins, so there's 400 choices. So you have to write a program that will try them until you get in. I just mentioned the #1 thing most students do is they copy the previous program, so they're in fact sending it to the previous form, where none of these will ever get you in. That can be pretty frustrating. First, you have to capture a request in Wireshark and find out what form it's going to. It is not going to the same receiver script as the previous one. And then Here's one with 4 accounts where you don't know the username or the password. You're going to have to guess them by hand until you get error messages that give you a clue, which is more realistic. And that's the game there. So those are the first couple of things to get started doing. Are there any questions about anything? Yeah.
Sorry for asking questions.
Yeah.
So I'm assuming that server's totally open. We're not going to get locked out by constant.
I'm glad you bring this up. My intention is for that server to be available for everyone. What happens, of course, is my servers are vulnerable and they get hacked all the time. So in fact, this server was down this morning and it may be down again. So here's the uptime report. The server was down for a couple of days. Now it's back up again. It may very well go down. This project isn't going to bring it down, but the other projects and other classes are pretty evil. And it does in fact get hacked pretty often. So it is entirely possible you will find the server has crashed. If so, please send me an email or remind me to put it back up. When the semester is going, it crashes a lot. Some of them stay up longer than others. They all have various vulnerabilities. But yes, in general, you can't trust it to always be up, but I try to keep it up. So if you're late on something because my server is down, you shouldn't lose any points for being late. Anyway, any other questions? This is a very good question. All right, well, I think I'm gonna, does anybody online need an ad code? These people here. Wait a few seconds and see if the chat message pops up, but it looks like it is not. So I'm going to terminate the online session and then I'll hand out ad codes in class. There's no need to broadcast them. So I'll stop this and that'll stop the recording. And then I'll